Hello students, in this video we are going to see the questions asked in JEE Advanced 2020 from the chapter Conic Sections. So they have asked two questions from this chapter. One question in paper 1 which is single correct answer type. It involves parabola as well as ellipse. And the second question is asked in paper 2, one or more than one correct answer type question. It is based on hyperbola and the tangent and normal. So if you wish, pause the video and give them a try. Let us look at the solutions of these questions. So the first question is this one: let a, b and lambda be positive real numbers. P is an endpoint of latus rectum of the parabola y square equals to 4 lambda x, which is standard parabola. And suppose the ellipse, this one standard ellipse, passes through the point P. If the tangents to the parabola and the ellipse at point P are perpendicular, then the eccentricity of the ellipse is. So in this question, okay, first of all they are telling P is an endpoint of latus rectum. So first let us draw the parabola, standard parabola. This is y square equals to 4 lambda x. Now we know that there are two endpoints of latus rectum. So what are the endpoints of latus rectum? We know for standard parabola y square equals to 4ax, focus is a comma 0 and the ends of latus rectum are a comma 2a and the other one is a comma minus 2a. Here also we will have two endpoints. One is going to be, so here in place of a we have lambda, so that is going to be lambda comma 2 lambda, and another is going to be lambda comma minus 2 lambda. Now we can choose P as any one of them, right? We can choose any one of them as P. We can choose this one as P or this one as P. It doesn't matter because the parabola is symmetric about x-axis and also this ellipse is also symmetric about x-axis. So it doesn't matter whether we choose this one or this one, we are going to get the same answer. So let us mark point P. So P is lambda comma 2 lambda. Now the tangent at point P to the parabola, let us draw the tangent. So the tangent will be like this. The tangent to the ellipse will be perpendicular to this. So this is, the blue line is tangent to the ellipse. We need to find the eccentricity of the ellipse. That means we need relation between A and B, right? So for that we can use these two conditions. First of all, the ellipse passes through point P, that is one condition. Another condition is the tangents to the ellipse and the parabola are perpendicular at this point. That means they are intersecting orthogonally. So let us apply these two conditions. Let us substitute lambda comma 2 lambda in this. So we have lambda square divided by a square plus 2 lambda whole square divided by b square is equals to 1. So this is one equation in A and B. Now let us use the other condition, slope of tangent to the parabola at this point, slope of tangent to the ellipse at this point. So let us, to find the slope of tangent, let us differentiate. So differentiating y square equals to 4 lambda x on both sides with respect to x, we will get 2y y dash is equals to 4 lambda. So therefore y dash is equals to 2 lambda upon y. So therefore, and what is y at P? The y value is 2 lambda. So therefore y dash at P is equals to 1. The slope of this green line, so slope is equals to 1. Now obviously slope of this is going to be minus 1 because these two are perpendicular. Product of slopes is minus 1. So slope of blue line is going to be minus 1. So to find the slope of blue line, let us differentiate the equation of ellipse with respect to x. So we get 2x upon a square plus 2y y dash upon b square is equals to 0. So from here we get, so bringing this 2x upon a square to RHS, we will get y dash is equals to minus b square x upon a square y. So now let us find slope of tangent at P. So slope of tangent to the ellipse at P, that is y dash at P. So in place of x we have lambda, in place of y we have 2 lambda. So minus b square lambda upon a square 2 lambda is equals to minus 1. So from here we'll get the relation between A and B. So this implies we have B square. So cancelling this minus 1 cancelling lambda, we'll get B square is equals to 2A square. So now from here we can see that B is equal to root 2 times A. That means B is larger than A. That means it is a vertical ellipse. So since it is a vertical ellipse, we know that eccentricity E square is equals to 1 minus A square by B square, because it is a vertical ellipse. So therefore eccentricity E square is going to be E square is equals to A square by B square is half, so that is 1 minus half, 1 minus 1 by 2, that is 1 by 2. So therefore E square is 1 by 2. So we have to be careful, because in the options there is 1 by 2 as well, but E is actually root over 1 by 2, that is 1 by root 2. So therefore E is equals to 1 by root 2 is the correct answer. So the ellipse will be a vertical ellipse, so it will look something like this. So let us move on to the next question. So this is a question based on hyperbola. So let A and B be positive numbers. A is greater than 1 and B is less than A. P be a point in the first quadrant. Suppose tangent to the hyperbola at P passes through 1, 0 and the normal cuts off equal intercepts on coordinate axis. Delta denotes the area of triangle formed by these three. E is eccentricity. Then which of the following statements is or are true? This is a multiple correct answer, right? So multiple, one or more than one correct answer type question. So we have to check all the 4 options. Now to find the eccentricity, see, first 2 options are talking about eccentricity. Third and fourth options are talking about the area. Now in this first 2 options, it is very easy to find the answer, because see here, this is a standard hyperbola. We know for standard hyperbola, E square is equals to 1 plus B square by A square. This is a standard hyperbola, x square by A square minus y square by B square equals 1. So eccentricity E square is equals to 1 plus B square by A square. And here clearly they have given that B is less than A. That means B by A is less than 1. So this means B square by A square. So this implies B square by A square is going to be less than 1, squaring on both sides. So that means this quantity is going to lie between 0 and 1. So therefore E square is going to lie between 1 and 2. So 1 less than E square less than 2. So that's it. Now from here we can easily say that 1 less than E less than root 2. That means in option A and B, option A is correct. Now for the second one, which talks about area of triangle. So let us draw the diagram of hyperbola. So let us take a point P in the first quadrant, A secant theta comma B tan theta. Now the tangent to this hyperbola at point P passes through the point 1, 0. So this point is 1, 0, a point on x-axis. Let us call this point as A. Now the normal to the hyperbola at P cuts off equal intercepts on the coordinate axis. That means that the slope of the normal is minus 1, right? Because cuts off equal intercepts on coordinate axis, so slope is going to be minus 1. So the normal will be like this. So x-intercept and y-intercept are equal. So the slope is going to be minus 1. So this one, slope is minus 1. Let us call this point as B, the point where the normal intersects x-axis. So this is B. So now they are telling area of triangle PAB as delta. Now we need to find the area of triangle PAB. Now to find the area of triangle PAB, okay, let us try to use the given information. So the tangent at point P, we know the equation of tangent at point P, that is nothing but S1 equal to 0. So the equation of tangent at point P is going to be x into A secant theta by A square minus y into B tan theta by B square equals to 1. So equation of PA, let me write the equation of PA. Equation of PA is going to be x by A secant theta minus y by B tan theta is equals to 1. So S1 equals 0. Now we know 2 things. One is, we know that this tangent passes through 1, 0. So let us substitute 1, 0 in this. So if you substitute 1, 0 this line passes through the point 1 comma 0. So if you substitute 1 comma 0, we will get 1 by a secant theta minus y is 0, so this will be 0 is equals to 1. So this implies secant theta is equals to a. Secant theta is equals to a. Now the other information we know about this is, see, the slope of normal is minus 1. So slope of tangent, the slope of green line is going to be plus 1. So that means from here we know that slope of this line is going to be plus 1. So slope of this line is going to be, so here slope is equals to, so if you bring y by b tan theta to right side and rearrange it, so we'll get slope as b secant theta upon a tan theta, and that is equals to plus 1. And we already know that secant theta is equals to a. Secant theta is a. So therefore substituting in this, so we'll get b is equals to tan theta, or tan theta is equals to b. So these two will get cancelled. So now let us try to find the area of triangle PAB with the help of these, right? So now for area of triangle PAB, triangle PAB is actually going to be a right angled isosceles triangle, because this is 90 degrees. Slope of this is 1, that means this is 45 degrees. The angle made with the x-axis, the angle made by tangent with x-axis is 45 degrees. So 45, 90, 45. This is right angled isosceles triangle. Let us draw this triangle PAB separately so that it will be more clear. So this is triangle PAB and these are 45, 45, this is 90. Now to find the area of triangle PAB, so let us drop a perpendicular from point P to x-axis. So that is this one PD. Let us call the foot of the perpendicular as D. Now if we can find the height is nothing but b tan theta, isn't it? So because this is y coordinate is b tan theta, so the height is b tan theta, and we know that tan theta is equals to b, so therefore the height is going to be b square. So the height of this is b square. So let us denote this in the big triangle. So we have this is b square. Now again this is also triangle PAD is right angled isosceles triangle, because this is 45, this is 90. So AD is going to be PD, that is same as b square. So this is b square. Similarly DB is also going to be b square, again right angled isosceles triangle. So therefore we know base and we know height. So therefore delta is equals to half into base into height, and base is 2b square and height is b square. So that's it. Therefore we have delta is equals to b power 4. So option D is correct, and option C anyway cannot be correct, because A is secant theta and B is tan theta. A cannot be equal to B. In fact we know that A is greater than B, right? So therefore the correct answers to this question are option A and option D. So that's it for now. So hope you liked these questions. See you in the next video. Take care.